In addition to classifying a data value as an outlier or as a usual value, we can also use z-scores to compare different data sets that don't really have anything sort of intuitively in common with each other. So in example 5, we want to consider these two very different scenarios below. In part A, in a given city, there are an average of 71,659.2806 ER visits each year, with a standard deviation of 785.8127. Assume that last year there were 72,258 ER visits in this city. Convert this value into a z-score. And then in part B, in the same city, an average of 3,599.8207 pounds of cocaine are seized each year, with a standard deviation of 102.9186. Assume that last year there were 3,609 pounds of cocaine seized in this city. We want to convert that value to a z-score. And then in part C, we'll look at determining which one is more unusual. So these two data sets have nothing really in common. The context is different. The numbers are very drastically different. But when we start in part A, converting this into a z-score, what we're going to do is put both numbers on a standardized scale. So we're taking this given data value, subtracting the average, subtracting the mean, and dividing by the standard deviation, 785.8127, to get a z-score of approximately 0.7619. Meaning this number of ER visits was less than one standard deviation above the average. When you do the same thing in part B, we take 3,609 and subtract the mean, and divide by the standard deviation. We get a z-score of approximately 0.0892. Converting both of these values into z-scores now gives us a standardized scale for making comparisons. Neither of these values are unusual because both z-scores are within that range from -2 to 2. But we can compare to see which one is more unusual, which one deviates further from the mean. And in this case, it would be the z-score of 0.7619, since that's clearly larger than the second z-score of 0.0892. And what that tells us is that the city, having 72,258 ER visits in 1 year, is more unusual. It's not actually an unusual value itself, but it deviates farther from the mean versus the z-score of 0.0892 is closer to the mean. So the 3,609 pounds of cocaine being seized is a much more likely value to see, since it's closer to the average based off that z-score.